All right, hello, ladies and gentlemen. All right, today we're going to talk about something called rigid motions and how they relate to proofs. Okay, rigid motions are basically just another name for transformations that result in a figure congruent to the original. Okay, that means um, anything, a line reflection. Okay, if you reflect a figure over a line, that image is congruent to the original. A point reflection, which is the same as 180-degree rotation, okay, that results in a figure that is congruent to the original. The only one that's not considered, that we talked about, that is not considered a rigid motion is a dilation, right? A dilation with a factor other than 1 or -1. Okay, that would change the size. It couldn't be a rigid motion. It won't be congruent to the original. Okay, so these include line reflections, point reflections. Okay, what are some other ones? Um, what are some other ones? Translation, right? Translation. Okay, we can even say rotation. Okay, rotation. Still can't get that one right. Rotations. Okay, so all of these are transformations that would result in a figure congruent to the original. All right, so what we're going to be doing from now on when we talk about proofs, we're going to say, or at least for this lesson, what transformation will map one of those triangles onto the other. Okay, it can be a single transformation or it could be a series of transformations. You might need more than one to get the figure to lie on top of the other one. Okay, so for example, I put together a bunch of the proofs that we've worked on minus the proofs. Okay, let's just assume we're proving these two triangles in example one congruent to each other. How can I map triangle ADB onto triangle ADC? What transformation would I use? Okay, so that should be fairly easy for you to see. Okay, if I reflect it over this line, if I reflect that ABD over AD, then it will map itself, it will land on the other triangle. All right, so I would say a line reflection over AD. Okay, when I ask you for a transformation, when I ask you for a rigid motion, you need to be specific. You can't just say a line reflection. You have to specifically say a line reflection over AD. Okay, that would be the easiest one for that one. Okay, so let's look at number two. All right, there's a couple of different ways we could do this. How can we map triangle AED onto triangle BCD? Okay, now remember, all of the corresponding parts have to lie on top of the other. It's like I'm lifting it off of the screen, turning it, flipping it, rotating it, setting it back down on top of the other one exactly. Okay, so what can you think of? All right, so I could say a couple of different things. All right, and this is going to be a series of transformations for this one. All right, imagine I can translate triangle BDC, and this is what I mean by being very specific. I have to be specific as far as how long and in what direction. I mean, how far and in what direction. So I have to translate triangle BDC, okay, along EC, okay, and I can say until C is on E. until point C is on E. All right, so I'm going to take this thing and I'm going to translate it this way until C lies on top of E. Then it's going to look like this. If I move it, it's going to be right there. Okay, and then what I have to do to get it to lie on top of AED, I have to then reflect it over AE. Okay, so I'm going to say then reflect over AE. Okay, so that would be one way of doing it. Okay, that would be one way of going ahead and mapping triangle BCD onto AED. Okay, get rid of some of these marks here. Okay, so that's one way of doing it. All right, can you see another way? All right, look at that carefully. Okay, another way might be, suppose I have this line right here. I can reflect one of those triangles over that line and have it lie on top of the other. So how would you describe that line? Okay, I could do a line reflection over the perpendicular bisector of EC. Okay, that way I know it's that line going right through D. Okay, perpendicular bisector of EC. If I reflect it, one triangle would lie on top of the other. So there's two different ways of describing that. You might be able to think of other ways of doing it. Okay, but the key here is to be specific. Okay, as to how far you're translating something, which line you're reflecting it over. Also, make sure that corresponding vertices actually lie on top of each other. Okay, if you look at number 3, okay, if I look at this, if I were to prove these two triangles, when we prove these two triangles congruent to each other, you might remember it was this angle and that angle. These two things bisected each other, right? So that line on top of that and this line on top of that. Okay, so how am I going to get all of those parts to lie on top of each other? Okay, I cannot I cannot reflect it over that line. Okay, if I reflect it over that line, sure, these parts would not lie on top of each other. Okay, this RS would lie on top of QR, and those do not correspond to each other. And TR would lie on top of PR, and those don't correspond to each other. So I can't use a reflection over that line. Okay, what I can do though is I can rotate, let's say QRP, around this would be TSR, no, TRS, around TRS, around, I should say, point R. I'm going to rotate QRP around point R 180 degrees. Okay, then that is going to have all of those corresponding parts lie on top of each other. Okay, I have a rotation. I have to say exactly how far, exactly how many degrees I need to rotate it to have one lie on top of the other. Okay, so that's what I mean by being specific. Okay, so what you can do for homework is you can try the rest of these. Okay, 4, 5, 6, and 7. Okay, and then there's also going to be some other practice proofs that I'm going to want you to do for homework also. Okay, so finish up this ditto, figure out what rigid motions will map one triangle onto the other. Okay, annotate it with Kami, and put it into the Google Classroom. All right, so see what you can do.